Hi, this is Mark Schuyler for another installment of our SAT prep. We're working in math right now, and we're specifically focusing on ratios, which are one of my favorite math concepts. Ratios are actually kind of like fractions, but they're not. There's a difficulty here that we have to explore. A fraction is normally the part over the whole, right? Of course, everybody knows that. The numerator is the part, the denominator is the whole. Unfortunately, and it's a big unfortunate, one of the three ways that we can write a ratio is as a fraction. We can say that the ratio of 9 to 1 can be written as 9:1, or it can also be written as 9/1, and it can also be written as 9 and then the English preposition to, T-O, 1, 9 to 1. We're going to end up using that ratio a little bit later. I have a good story about a student of mine who was absolutely obsessed with finding a college in America that had the highest ratio of girls to boys. That was the college he wanted to go to. Lots of good reasons to pick a college, right? I mean, there's does it have the major that you're interested in? Is it the right price for your budget and your parents' budget? Is it in-state or well out of state? But for this young man, the only thing that mattered is that he had the highest ratio of girls to boys. Well, all of that being said, we want to talk about, well, there's a little problem here with ratios, and a lot of my students, frankly, screw up because when they see a ratio, especially when it's written as a fraction, they start to think in terms of the part over the whole. But that's not the way ratios work. Even though they can be written as a fraction, they are the part to the part over the part. So the secret to ratios, and I cannot emphasize this enough, the secret to being able to solve most ratio problems on the SAT is to realize it's very helpful to add ratios together. For example, what's the smallest number of students who could be enrolled at a college that has a known ratio of 9 to 1? I'll let you think about that for a second. What is the smallest? It'd be a very small college indeed, but what would be the smallest number of students who could be enrolled at a college that has stated its ratio of girls to boys is 9 to 1? And of course the answer is 10. Is it possible for this college to have 15 kids enrolled, a total student enrollment of 15 students, if they have a 9 to 1 ratio? And of course the answer is no, they could not. You'd have to double the number of girls, which would go from 9 to 18, and you'd have to double the number of guys to keep the ratio 9 to 1. So you'd have 18 girls, 2 guys, for a total of 20 kids enrolled at this college. What's the next possible number of students enrolled at our fictitious college? Well, the answer is not 40, it's 30, because it will always be a multiple of 10, which is what we came up with when we added together the original ratios of 9 to 1. So if you're on a tour of this college and your tour guide, who's very peppy, says, we have actually 3,942 kids enrolled, and it's a perfect 9 to 1 ratio, well, you know something is wrong. Either her ratio is not quite exact, it's not exactly 9 to 1, or there really are not this exact number of students enrolled, because it ended with a 2, and any ratio that was correct would have to end in a 0, because then it would be a multiple of 10. So that is one of the biggest problems with ratios, is you have to remember that it's very helpful to add ratios together. I'm going to do a little bit more advanced lecture on ratios in a moment, but I wanted to give you an introduction to ratios.